A particle of mass 0.2 kg vibrates with a period of 2.0 seconds if its greatest displacement is 0.4 meters. What is the maximum kinetic energy? You have to find the maximum kinetic energy. So solution, let's bring out what is given in the question. A particle of mass, that is m, is 0.25 kg, right? Vibrate with a period of 2.0 seconds, that's t is 2.0 seconds, right? If its greatest displacement is 0.4 meters, greatest displacement simply means the radius, which is r, the distance or the radius is 0.4 meter. Okay, what is the maximum kinetic energy? So I'm asked to find my kinetic energy, right? We know that kinetic energy Ke, right, is equal to half mv square. Good, half mv square, right? Now for a simple pendulum, our v is what? Angular velocity times radius, right? Good. Now if you look at the question, v is not given, so we have to calculate our v, and before calculating v we have to calculate our angular velocity. We don't have angular velocity, so the things that we need to do is that we first of all calculate our angular velocity. After calculating angular velocity, we now calculate our linear velocity. Then we now bring the linear velocity into this formula and find our kinetic energy, right? So let's go there. The first thing is, let's calculate for our angular velocity. What's the formula for angular velocity? Equal to 2 pi f, right? Good. But in this case, frequency is not given. And recall that frequency is equal to 1 over period, right? Now if I replace my periods, my frequency and mean here, what am I going to have? My angular velocity is going to be 2 pi times 1 over period, right? Are you understanding me? Good. Now I'm going to have angular velocity is equal to 2 pi over t. This is what I will use to find my angular velocity first. Good. So let's go. This is equal to 2. My period is what? 2, right? 2.0, which is the same thing as 2. Okay. So my angular velocity, 2 will cancel 2. So I have pi rad is per second. Do you understand me? So our angular velocity is pi rad per second, right? Now we've calculated our angular velocity. The next thing is we are going to calculate our linear velocity. Then we take it back to the equation of kinetic energy. We use this. So my v is equal to angular velocity times my radius, right? So v is equal to pi. The radius is what? 0.4, right? So I have 0.4. So if I multiply v, I'm going to have 0.4 pi meter per second. Is that clear? Are you with me? Good. Now we have our v. We now bring our v into the kinetic energy now. Therefore, our kinetic energy Ke, what are we going to have? Half mv squared, right? So I'm going to have is equal to half times my mass is given as what? 0.25. Good. 0.25 times my v that we calculated, 0.4 pi, right? So I'm going to have 0.4 pi, right? I'll put them in bracket square, right? 0.4 pi. Good. Now we are going to simplify. I have 1 over 2 times 0.25. Let's open this bracket. Times, if I will find the square of 0.4 and the square of pi. So what is the square of 0.4? That is 0.4 times 0.4. What do we have? 0.16. So here I have 0.16 and pi square. 0.16 and pi square. Good. The next thing is we multiply 0.25 with 0.16. 0.25, so I have 1 over 2 times is what? 0.04, right? 0.04, right? Square. Good. Now, the next thing that we are going to do, this can be written as 0.04 pi square divided by 2. So divide this number for me. 0.04 divided by 2. 0.02 pi square, right? Now let's simplify the value of our pi and substitute. Okay, now I have 0.02 times the value of our pi is either 22 over 7 or 3.142 square. Good. The square of 3.142 is 9 what? 87, right? Good. Multiply this. 0.02 times 9.87. What do we have? 0.19. 0.19 joules. Right?